Question number 144. dy by dx is equal to 2x plus 2y minus 2 by 3x plus y minus 5. The given equation is a non-homogeneous equation. So we have to convert it into a homogeneous form using proper substitution. So let's call this given equation 1. For such question, we have to first check whether the ratio of coefficient of x in the numerator and denominator is equal to the ratio of coefficient of the y in numerator and denominator. So if they are equal, the solution cannot be applied. So when we check, it is 2 by 3 and 2 by 1. So it's not equal and we can apply the solution. So the substitution in such cases will be small x is equal to capital X plus h and small y equal to capital Y plus k. Let's call this equation 2. Now differentiating equation 2 with respect to x, we have d small x is equal to d capital X, d small y equal to d capital Y. From this we have dy by dx is equal to d capital Y by d capital X. Let's call this equation 3. Now we have using 2 and 3 in 1, we have d capital Y by d capital X is equal to 2 capital X plus 2 capital Y plus 2h plus 2k minus 2. Just substituting x for capital X plus h and y for capital Y plus k, we get this by 3 capital X plus capital Y plus 3h plus k minus 5. Let's call this equation 4. Now the equation 4 is not homogeneous, but if we find h and k such that 2h plus 2k minus 2 is equal to 0 and 3h plus k minus 5 is equal to 0, the whole equation goes to a homogeneous form. So to find h and k, we use the two equation 2h plus 2k minus 2 equal to 0 and 3h plus k minus 5 equal to 0. So solving these two equations, we have h by 5 into 2, 10 minus 2 into 1, minus 10, 2 into minus 5, minus 10, minus 1 into minus 2, so plus 2 is equal to k by minus 2 into 3, minus 6, minus 5 into 2, minus 10, so plus 10 is equal to 1 by 2 into 1, 2, minus 3 into 2, 6, 2 minus 6. So we have h is equal to minus 8 by 2 minus 6 is minus 4, which is equal to 2. And y equal to minus 10 minus 6 is 4 by minus 4 equal to minus 1. So h equal to 2 and y equal to minus 1. Let's call this equation 5. Now from equation 5 we can also write capital X is equal to x minus h, where h is 2. So 2, and capital Y equal to small y minus k, which is equal to plus 1. So we will call this equation 6. We will be using this equation 6 later in the solution. So capital X is x minus h from equation 2 only. So using equation 2, we can write capital X is equal to x minus h, h is where h is equal to 2, and y minus k is y plus 1. So okay. Now we have 5 and 6. Using the values of h and k from equation 5 in equation, putting values of h and k from equation 5 to equation 4, we get dy by d capital X is equal to 2x plus 2y by 3x plus y. Now we will call this equation 7. This is a homogeneous form. For such homogeneous form, we have the substitution y equal to vx. Let's call this equation 8. Differentiating equation 8 with respect to x, we have dy by dx is equal to v plus x dv by dx. Let's call this equation 9. So using 8 and 9, in 7 we have v plus x dv by dx is equal to 2x plus 2vx, putting y equal to vx, 3x plus vx. Now cancelling x from numerator and denominator and bringing v to the right side, we have x dv by dx is equal to 2 plus 2v by 3 plus v minus v, so which is equal to 2 plus 2v minus 3v minus v square by 3 plus v. Further simplifying, we have x dv by dx is equal to 2 plus 2v minus 3v is minus v square by 3 plus v. Okay, now this form is now from this form we can use the method of separation of variables and solve. So bringing all the v terms to one side and x terms to the other, we have 3 plus v by, we will take minus sign out from this numerator and put it in the other side. So we have, when we take minus sign out, we have v square plus v minus 2 dv equal to, say I'm putting this, the minus sign here outside, multiplying both sides by minus sign 1, we can say, so minus dx by capital X. Now we can split this term in a form where we can easily integrate. So to integrate such terms, what we will do is we'll split 3 plus v into two, where first part is the differential of the denominator and second part is the remaining of 3 plus v. So the differential of the denominator is 2v plus 1. Okay, differential of denominator 2v plus 1. So we will write half into 2v. So we get v, which is what the coefficient of v in numerator in the previous step. So we need 2v plus 1, right? So we write 2v plus 1. So when we open the bracket, we have v plus 1 by 2, right? So we have a 3 here. So additional 1 by 2 is in the numerator. So we subtract it by 1 by 2. So when we open this bracket and simplify, we have v plus 1 by 2 plus 3 minus 1 by 2. So when 1 by 2 cancel out, when we open up, we get 3 plus v. So we can do that, and v square plus v minus 2 dv equal to minus dx by x. Now we'll split the terms and integrate. We will integrating. We will save one step. Integral 1 by 2 2v plus 1 by v square plus v minus 2 dv. So 6 minus 1 by 2, 3 minus 1 by 2 is 5 by 2. So plus 5 by 2 integral 1 by v square plus v minus 2 dv equal to minus integral dx by x. We'll put a constant c. Now this is very easily integrable. First integral is half into the differential of the denominator is in the numerator, so we can write right away half log v square plus v minus 2 as the different integral of this first integral, solution to the first integral. And now to integrate this, we convert it into a standard form. So v square plus v can be written as v plus 1 by 2 the whole square. So what will be the terms? V square plus 2 into 1 by 2 into v becomes v plus 1 by 4. There is a 1 by 4 additional here, so minus 2, there is a 1 by 4, so here it becomes 1 by 4, right? So if we open up these two brackets, we will have v square plus v minus 2 only, right? Okay, the reason why we split the denominator into this form is we can then use the standard integral formula to solve this integral. So okay, we'll do that in the next step. So minus dx by x becomes minus log x plus c. So this integral becomes half into log v square plus v minus 2 plus 5 by 2. So the standard integral formula is, to remember, integral dx by x square minus a square is equal to 1 by 2a log x minus a by x plus a. So this is the standard formula. We will be using that here. Let's bring it down. Okay, we will be using this formula to solve this one. Sorry. So that becomes 5 by 2 into 1 by 2a. Here a is 9 by 4. 9 by 4 is a square. So here it is v square minus a square, right? A square term is 9 by 4. So a becomes 3 by 2. If we simplify this into one term, to add it into one term, we have 9 by 4. 9 by 4, and which is a square. So a is equal to 3 by 2. So 2a, 2 into 3 by 2 log a plus x. Sorry, x minus a. X minus a is v plus 1 by 2 minus 3 by 2. And v plus a, which becomes v plus 1 by 2 plus 3 by 2. Minus log x plus c. So we can cancel this 2 and 2. There is a 6 in this denominator. We will multiply throughout by 6 and bring the log x term to the LHS. 6c becomes another constant, so we will just multiply throughout by 6. And v square plus v minus 2 can be split into this is sum is 1 and product is minus 2, which can be split to v plus 2 into v minus 1, right? 2v minus, so product is minus 2 and sum is 2v minus v, which is v. So this can be split into that form. So we have 3 log v plus 2 into v minus 1. How did we are going to multiply throughout by 6, so that this denominator, the 6 in this denominator goes like cancels out. So we are multiplying throughout by 6, so 6 by 2 becomes 3 plus 6 goes, so 5 log v 1 by 2 minus 3 by 2 is v minus 1. So v minus 1 by 1 by 2 plus 3 by 2 is v plus 2. V plus 2 plus log 6 log x is equal to another constant c1, where c1 is equal to 6c. So we have this Now combining, using the logarithm property and combining, we have log v plus 2 into raised to 3 raised to 3 into v minus 1 raised to 3 into taking 5 inside, so v minus 1 raised to 5 by v plus 2 raised to 5 into x raised to 6, okay, equal to C1. Now we can simplify this further. Before that, we can take e to the power on both sides. We have to eliminate this log function we have. So, and simplifying, we have v plus 2 the whole cube and v plus 2 raised to 5 cancels out. So v minus 1 okay, let me just check. This 3 2 v minus 1 5 6 8 v minus 1 raised to 8 into v plus 2 by v plus 2 3 gets cancelled and 2 into x raised to 6 is equal to e raised to c1, which becomes c2, where c2 equal to e raised to c1. Sorry. Okay, now we get this. Now we can apply from equation 8 that v equal to y by x. From equation 8, v equal to y by x. So before that, let's take square root of both sides so that it further simplifies. Let me just before that, let me just confirm whether 3 okay. So if we take square root, we have v minus 1 raised to 4 by v plus 2 into x cube is equal to root c2. We'll call it c3, where c3 equal to root c2, another constant. So we have this. Now using 8 y by x, when we put y by x minus 1 y by x plus 2 all raised to 4 into x cube equal to c3. Therefore, we simplifying, we have y minus x raised to 4 and y plus 2x by x raised y by x minus x raised to 4. So here there is an x raised to 4 and here there is an by x and here there is x cube. So this is equal to c3. Now this x cancels with this cancels out. So we have y minus x raised to 4 is equal to c3 into y plus 2x. So now we got an equation. Now we have substitute from equation 6. So there is equation 6, capital X is equal to small x minus 2 and capital Y equal to y plus 1. We can use the substitution y plus 1 and x minus 2. So y plus, using 6, we have y plus 1, sorry, this is small y plus 1 minus x plus 2 raised to 4 is equal to C3 into y plus 1 plus 2 into 2 into x plus 2. So this becomes y minus x minus 1 minus 2. 1 minus 2 is minus 1 raised to 4 is equal to C3 into y plus 2x plus wrong. Substitution was y plus 1 and x minus 2, right? From equation 6. Right. X minus 2 and y plus 1. I put x plus 2 by mistake. So it should be x minus 2. So this mistake, and so here it is x minus 2 and x minus 2. So we have y minus x 1 minus minus 2 is plus 3 raised to 4 is equal to C3 into y plus 2x 1 minus 4 minus 3. So the final answer is y minus x plus 3 raised to 4 is equal to a constant into 2x plus y minus 3. So this is the solution to question number 144, and these are the steps to the solution. So this question uses a standard formula. If you are not familiar with this standard formula, please do check this out. Like, if there are so many standard formulas that you can use to solve questions of ordinary differential equation. If you remember, if you by heart it, it will steps becomes very simple and straightforward. So okay, this is the only standard formula that is used. So yeah, so this is the solution to question number 144.